Hello, you're welcome. You're welcome onto my channel today, and it gives me great joy to observe you having this video. Hi, I'm Dr. Olayinka Akanle. I'm a researcher, I'm a sociologist, I'm a lecturer in the university. And on this channel, I do a number of stuff, but all these stuff that I do, you can easily cluster them into four: sociology, research, relationship, and migration. And I have playlists on this channel that can take you to all these four clusters so you can catch up. Meanwhile, are you subscribed onto this channel? If not, what are you waiting for? Kindly go ahead and subscribe. Click subscribe on your screen right now. Tap subscribe on your screen right now to subscribe to the channel for wonderful content that will do you enormous good. The title of this video you are viewing is Cluster Sampling in Quantitative Research. Sampling is very important in research, and the quality of your sampling will determine the quality of your research. The quality of your sampling will determine the quality of your research. I've dropped many videos on sampling, in qualitative, study and sampling in general terms, data collection methods in quantitative, into qualitative, many videos on research, so view to catch up. So this particular video is within the quantitative research framework, and this is very important because in quantitative research, sampling must be based on probability. That is, every member of that population must have chance equal of being selected. So, and representativeness is very important to us in quantitative research because we want to generalize ultimately and get reliable representative finding that we can generalize. So based on this, we are very much concerned about getting our samples very correctly, to the extent that the sample will have all the elements of the total population. This is only when we can generalize our findings. So, and it is very important to note that cluster sampling is a very important component. I dropped a video on systematic random sampling, and I told you there are different types of sampling method in quantitative. I mentioned you have stratified random sampling, you have systematic random sampling, and I told you that even you have cluster sampling and you have systematic. So you have all these four, and I will drop video on them, and you have simple random sampling, so making four. And I will drop this video on all of them. So I've dropped video on systematic random sampling. I'm dropping this one you are viewing on cluster random sampling. On cluster sampling. I'll drop another one on simple random. I'll drop another one on stratified. So stay tuned. So now, what is cluster sampling in quantitative research? It's pretty straightforward. Cluster simply means groups. Creating groups as different independent categories from a total population. That's what I mean by cluster. So cluster is a technical word for groups, different groups. Grouping is the same thing as clustering. So when you say cluster, it means group. So cluster sampling means, dividing the total population into small groups regarded as cluster. So it's from these small groups that you will then begin to pick your sample. But these small groups must have important semblance, must be identical to the general population. Because the essence of this is that you cannot administer your instrument on everybody like a sensor. You may not have the fund, and you may not have the capacity, you may not have the time. So you want to pick samples that are very representative of the total population. Therefore, you want to see the best way to go about it. You might want to say, okay, let me first group this general population into smaller units. This smaller unit will represent the total population. Then I will then pick my sample from these smaller groups in a way that will resemble me talking to the general population. So, and these small groups must be based on your unit of analysis, your interest. So that you want to be able to do this, so that you are sure that you have manageable groups through which you can easily, correctly pick your sample. So that's why you are clustering. That's what I mean by clustering. So that is, you are bringing people of identical elements together as a group, through which we will now pick. But these groups are still from the general population. You're only doing this to be sure that you are able to manage the population in a way that you can then begin to pick easily, in a clear way, rather than being confused. And this is very important. So clusters can be maybe local government areas, can be states, can be districts, can be communities, can be schools, can be, it just depends on what you want to make to be the basis of your clustering. Your clusters must have basis, and this basis will be dependent upon your research objectives. Do you want to cluster by gender? Do you want to cluster by age? Do you want to cluster by level of education? Do you want to cluster by locality? Do you want to cluster by geography? So it depends. But it's your research orientation and agenda and your objectives and the resources that you've got that will determine the number and the nature and the parameters of the clusters you are looking for. So this is very important. It's based on your unit of analysis. What do you want to explain? And what are the social demographics or elements that are important that you don't want to miss? The essence of using clustering sometimes is that you don't want to miss out on important elements. And if you just do it like simple random sampling or systematic random sampling, you don't trust that you will not make mistakes. So you want to break it down. Good, I love that word. Break it down by bringing important elements, important variables to form groups. And the clusters must be unique and they must be fit for purpose. You must have a purpose at the back of your mind. And this cluster sampling is very good for large population so that you don't get missed in the jungle of the large population. You don't get missing, and you don't get things mixed up if you just jump into the ocean of the sample. So you want to break them into smaller units, smaller groups that we technically refer to as cluster. And this is very important so that you can have representation because you want to generalize. So we have types of cluster sampling. We have single stage, whereby you have divided them into clusters, into groups. You just simply begin to pick your samples from the groups. Then you have double stage, in which case you have created the clusters. Then you are recreating another cluster from the cluster, so that you can then sample based on the layers that you have created. It's still to be able to break it down to smaller units at the same time. Then you can have multi-stage, in the sense that you first bring them together as clusters, then you break them down again to smaller units, then you break down again to smaller units, the same cluster, then you break down again to smaller units until you get to a point that you are sure that you can then begin to sample across the stages in the same cluster. But it depends on the complexity of the research you are doing. So if you are not doing a very complex research, simply stay with your single stage clustering. Break them down by that category. But if you still want to disaggregate along different variables within the same cluster, that's why you then decide whether you want to do double stage or you want to do multi-stage. So, but all of this is to be able to get the best result from all of this you are doing. Now, what are the steps? What are the steps in cluster sampling? One, you must define your problem. What is the statement? What is the problem you want to understand? You must be clear. You must determine that cluster sampling is the best for you based on the way I've explained it. And if you view other videos too, the one I've released and the one that will still released, it can help you to make more informed decision. Then you must define the population. What is the general population of study? This is very important. Then you determine your sample size. I mentioned in my video on systematic random sampling, you must have determined the sample size. You have different formulas for this. You can't just pick your sample size just the way you want. No, you might have to use formula. We have different formulas for this. We decide to use Taro-Yamani formula for determination of sample size, for known population. You may use Cochrane. So there are many of them, but this formula must be used to determine systematically and scientifically your sample size. So once you are determining this, then you can then begin to randomly select from the clusters. Then after you randomly select, then you collect your data, Then you analyze your data. But important is, why I go to data collection and analysis is that when you analyze your data, you must disaggregate your data based on the different clusters. You must disaggregate and analyze based on the clusters you have created. You cannot lump the analysis together anymore. Then you have advantages and disadvantages of this. A major advantage of cluster sampling is that it saves time because you have broken them down. So it's easier for you to do what you want to do. Then it's cost efficient. Rather than just jumping into the jungle, the ocean of the large population. Once you break them down, you break the population down into clusters, then you are able to spend your money clearly. Then it can give you high representativeness because you have broken down into clusters. So you are sure of why you are breaking and how you are breaking. So it's then easier for you to be able to pick your sample clearly. Then it gives clarity because you have broken down into smaller units. You are clear of sample you want to collect and where you want to select your sample you want to select, and how to select them. But it has a very serious disadvantage, which is also complex. Look at it, especially if you want to go to multi-stage clustering. So it can be, before you now begin to break down, determine the variables upon which you want to break down, the elements you are looking for. So that can be complex. Then you can still have bias because you're the one that will determine the group you want to create, the variable you want to determine. So the fact that everything starts with you and ends with you can also force you to be biased if you're not careful. Then you can have likelihood of error in it, internal validity issue, in the sense that you're the one making the decision how you want to break them down on what variable. So bias can come into it, and you can make errors because when the processes are too layered, it can create problem for you, and that is very serious. But generally speaking, cluster sampling, I love it. I've used it severally. But it's my duty to explain to you the pros and the cons and the types and the meanings. So based on what I've explained, and if you feel this along my other videos on sampling, you can then make informed decision. Cluster sampling is very good and is very interesting. But I'll give you the advantages and disadvantages and what it means and types. Then you can then see what is best for you. Till I see you in my next video, kindly click subscribe, tap subscribe, and spread information about this channel as a strong one and beneficial one. Till I see you in my next video, bye for now.